Dear students, today we are going to study an important concept called angular momentum. Let's look at some key terms we will need to understand this lecture. The first key term is spin. Spin is when an object turns around a central point or axis, like a spinning top or a planet rotating in space. It's the action of rotation that you see when something is twirling in circles. Now, the next comes linear momentum. Linear momentum describes the amount of motion an object has when it's moving straight ahead. It combines the object's mass, how heavy it is, with its speed, how fast it's moving. For example, a heavy truck moving slowly has a lot of linear momentum due to its mass, while a fast-moving bicycle has a lot of linear momentum because of its speed. The third key term is angular velocity. Angular velocity tells us how quickly something is spinning around an axis. It measures the rate at which an object rotates, like how fast the hands of a clock move around the center. For instance, a spinning wheel with fast-moving spokes has high angular velocity. Now let us understand the term moment of inertia. Moment of inertia is a measure of how difficult it is to change an object's spinning motion. It depends on how the object's mass is spread out from the axis of rotation. For example, it's easier to spin a figure skater with their arms pulled in close than with their arms extended, because pulling the arms in decreases the moment of inertia. The final key term is angular momentum. Angular momentum, L, describes how much spin an object has, taking into account both its rate of spinning, angular velocity omega, and how its mass is distributed, moment of inertia I. For example, a figure skater spins slower when she opens her arms out, resulting in a change in angular momentum. When we study angular momentum, we define the direction of movement. For this, we use the right-hand thumb rule. If the curled fingers of your right hand show the direction of rotation, then your thumb points in the direction of the angular momentum vector. Now, let's explore the effect of moment of inertia on angular velocity. We observe that if the moment of inertia I increases, the angular velocity omega decreases. Conversely, if the moment of inertia I decreases, the angular velocity increases. Let us see a figure skater in action. We can see that when she extends her arms away from her body, her angular velocity is lower. However, when she folds her arms in, her angular velocity increases.